Hello. Just a quick note on the equation of motion when we are writing them in frames that are not inertia frame, they have acceleration. So this is equivalent to frames that accelerate, moving with constant velocity. That's fine. That can be considered inertia. But when there is acceleration, as in this point P is moving with some acceleration. So what we can do in translation or linear equation of motion, this is linear equation of motion. So we know mi or I double dot equals Fi. But if we are writing this equation from a perspective of an observer in frame that moves with P, I can write it as mi r double dot P plus rho double dot I equals Fi, or m rho double dot I, what the acceleration that the observer sees, is Fi minus mi r double dot of P, the acceleration of the point of the observer itself. So what we can see is, well, essentially, this equation tells us that if we are writing equations from a perspective of a non-inertia observer, we can still write m times acceleration equals f, but we have to consider the effect of some kind of inertial forces that need to be included to make the equations work. Similarly, we saw in the previous video in the angular domain that angular momentum about point P was moments about that point P, but minus rho I cross, again, same inertial force, mi r double dot P. So it is the same inertial force, and now we are looking at the moment of the inertial force that must be included in the equations to make things work. So in other words, if you are accelerating and you're an observer observing a motion, your acceleration affects the equation. So keep that in mind. Okay, that's all for now. There is one maybe very big video coming up, and that would be it.